All right, so this is the atom lecture. This is lectures part 2, where we will be continuing on talking about the structure of the atom. So why are all atoms electronically neutral? Normally in an atom, the number of electrons within the electron cloud is equal to the number of protons in the nucleus. The positive and negative charges cancel each other out. Therefore, the atom is said to be electrically neutral. If an atom gains or loses an electron, the atom is no longer neutral. And this can happen if the atom absorbs or releases energy, which happens all the time around us, right? The atom is then called an ion. All right, because it's no longer an atom because it's not electrically neutral anymore. So it's considered an ion. It's important to remember in an atom, the number of positively charged proton is always equal to the number of negatively charged electrons. Isotopes. All atoms of an element have the same number of protons, but the number of neutrons can vary. Atoms with the same number of protons and differing number of neutrons are called isotopes. They can't be atoms anymore necessarily. They have to have a new name. Some isotopes are unstable. The nucleus of unstable atoms do not hold together well. So you have radioactive decay. Is the process whereby the nucleus of an unstable isotope releases fast-moving particles and energy. Okay, this was discovered by Henry Becquerel. I don't know, another name I'm not very good at pronouncing. So if we're looking at this, how many neutrons does magnesium have? Okay, it has -30, and you're like, what? How? Well, we'll subtract the atomic number from the mass number. All right, this has been rounded up a little bit, but if we subtract 25 from 55, we have the -30, okay, because there's more of them than of those when we're subtracting. How many electrons per shell? Each shell, okay, this is shell 1, this is shell 2, and this is shell 3. They're like layers. Each shell has a maximum number of electrons that it can hold. Electrons will fill the shells nearest the nucleus first, so it will make sure it has the correct number here, then the correct number here, and then the correct number here. So the first shell holds a maximum of 2 electrons. The second shell holds a maximum of 8 electrons, and the third shell holds a maximum of also 8 electrons. So draw the diagram from the previous slide in your notebook and label it correctly. When you are done, make sure you submit in Google Classroom what the diagram was about and that you completed it for credit. Okay? And then when you are done with that, just come back and continue with this PowerPoint lecture. So the most stable configuration of electron in an atom is when it has a full outer shell. That means it was able to fill each one of its shells, including the outer shell. If all of those are filled, they are considered stable. They're not looking for any, or they're not trying to get rid of any. So write this down, people. What is a covalent bond? A covalent bond is a chemical bond that results from sharing valent electrons. So see how here on the outer shells they're sharing? Okay? So the molecules, when 2 or more atoms bond covalently, that means they stick together, the shared electrons are part of the outer energy level. Generally, they form between non-metallic elements. Okay? Ionic bonds. Ionic bonds is when one atom gives up 1 or more electrons. If an atom is missing an electron, it is called an ion. Remember, we talked about that. So an atom with a spare electron, it has too many. Here's an atom that needs an electron to become stable, so it sucks it away. It pulls it away, okay? Non-covalent bonds, right? You have polar and non-polar bonds. Remember polar opposites, think of magnets, okay? So non-polar covalent bonds equal sharing of electrons. Polar covalent bonds, they're unequal sharing, so they're like repelling, they don't want to cooperate. And ionic bonds, no sharing of electronic bonds at all. Okay, so increasing differences in electronegativity. So it's become negatively charged the farther it goes down. Positive charge, more negative charge. So what does this have to do with biology? Well, organisms are living things. They can be anything from a small unicellular organism to an elephant, a human, or a plant. Anything that is live is an organism. So there are 5 characteristics that all living things have in common. All living things use energy. All living things will respond to their environment. Living things are composed of cells. Cells are basic units of all life, and to be alive, something has to be made up of cells. All living things will be able to maintain homeostasis, which means they can keep a balance, like we keep a balance of our temperature and how much water we have in our body, which means they can maintain their internal environments, and all living things are able to grow and reproduce. We will go over all of this a lot later, okay? That's really what the rest of the class is about. So living things are structured from very, very small to large. All living things are made up from atoms, and these atoms compose molecules. And then it then combines into cells. So you have atoms, molecules, cells, tissues, organs, organ systems, and then organelles, like you. You're an organelle because you have organ systems that are put together. So this is where atoms come into play. All right, so here is a diagram, and here you are as an organism or an organelle. Okay. So in your notebook, you're going to draw the diagram from the previous slide, like you've done before. But I want you to make the drawing of the organism to resemble you. So give it your color hair, your color eyes, maybe draw it in your favorite outfit. You can draw it doing your favorite activity, whether it's dancing or skateboarding or horseback riding or driving a truck, whatever it is. But do that drawing. And then when you are done, if we're distant learning, you need to go onto the Google Classroom and submit that you have finished that. Now, if we're meeting in person, I will check your drawings then. If we are not meeting in person at the time that we're doing this, then I will do a notebook check and check for this drawing when we get back. All right? Awesome. So atoms are the basic unit of all living organisms. In this course, you will learn and understand about each step of the organ system. All right? So that's what it's about. So it took I broke it up into 2 videos. You can go as fast as you want, as slow as you want. Just make sure you complete it. When we are meeting in person, I'll do a notebook check. And if we're doing distant learning, I will do the notebook check the next time we meet together. Or sometimes I will have your parent or guardian do a notebook check for me. If you have any questions, Google Doc me and I'll get back to you. Thanks.